To explore even the nearest worlds of our solar system, a spacecraft must journey across hundreds of millions of kilometers of interplanetary space. But in the process of doing so, it may also reach back across billions of years of cosmic history. On Earth, tracing that history presents an enormous challenge. The ceaseless movements of water, ice, wind, and volcanic eruptions, as well as the actions of a diverse and complex array of living organisms, all combine to create a planet that is never at rest. Our world is a world of the present, a world of change. To access our past, we must leave Earth behind and find those places that time has left untouched. On September 17, 2007, a NASA spacecraft began the most ambitious journey yet back through the 4.5 billion years of our solar system's history. Its goal, to open a window into a distant era when the planets as we know them today were still just forming. Fittingly, it's called the Dawn mission. While the secrets of the solar system's early history remain elusive, the place to hunt for those secrets is not. It is the Asteroid Belt, a zone of flying rocks and miniature worlds that forms a vast ring of material orbiting around the Sun. The Asteroid Belt is a place of transition between the inner solar system, where small rocky planets like Earth are found, and the outer solar system, where the planets are massive spheres of liquid gas. And it's here that scientists are seeking insights into a different transition, the one that billions of years ago led from small bits of cosmic dust and debris to the planets that populate our solar system today, including at least one such planet, our own, that is capable of supporting life. There are hundreds of thousands of objects in the asteroid belt. Most are only a few kilometers in size, tiny flying mountains that tumble namelessly through space. But a handful of asteroids are hundreds of times larger than that and much more interesting. In fact, they are just large enough to reveal the first steps on the way to making true planets. Dawn's mission is to explore the two most massive asteroids, Ceres and Vesta. Both were discovered more than 2 centuries ago, even before astronomers realized there was such a thing as an asteroid belt. Now they are believed to be relics from a far more distant past, when objects that were several hundred kilometers in size became the building blocks of the solar system's rocky inner planets. The asteroid belt is the place where such objects can still be found. But even here, they are rare. Most of them were broken apart by collisions with other asteroids long ago. As the largest survivors of this celestial shooting gallery, Ceres and Vesta are especially important to scientists. But until now, the best views we've had show them as little more than blurry, uneven blobs. Here, the Hubble Space Telescope has taken enough images of Vesta to show the asteroid rotating on its axis. But there is only so much that can be learned from this distance. So, with a sophisticated suite of instruments and a long list of questions, the Dawn mission set out for the asteroid belt, with Vesta as its first stop. Once free of Earth's gravity, Dawn spread its 2 enormous solar panels, giving the spacecraft the appearance of a great bird in flight. The panels are part of an innovative propulsion system that generates electricity from sunlight and uses it to drive a high-speed stream of ionized xenon. This method has proved ideal for pushing Dawn along its complicated flight path, which took it past Mars in 2009 and onward into the main asteroid belt. But this is not the first time spacecraft have explored this rocky region of the solar system. In 1991, the Galileo mission on its way to Jupiter passed near enough to the small asteroid Gaspra to return this image, the first ever asteroid close-up. 2 years later, Galileo passed a much larger asteroid named Ida and discovered that it was circled by a tiny moonlet which scientists dubbed Dactyl. In 1997, the NearEarth spacecraft saw a very different looking kind of object when it passed near the asteroid Matilda. And finally, in 2010, Europe's Rosetta mission captured this view of Lutetia. At over 100 kilometers across, it was the largest asteroid yet to be revealed. Yet all of these views, taken by spacecraft on their way to other destinations, are tantalizingly brief. This time, scientists were planning for a very different kind of encounter, one that would allow them for the first time to orbit and survey in detail the two giants of the asteroid belt. By July of 2011, that encounter was set to begin. After 4 long years, Dawn was finally approaching its first stop, Vesta. As Dawn's cameras zoomed in on their target, scientists prepared to open a new chapter in asteroid exploration. They would not be disappointed. 350 million kilometers from the Sun, the battered surface of the asteroid Vesta bears witness to the solar system's violent beginnings. This is the view from the Dawn mission, the first spacecraft to closely examine Vesta in an effort to tease out some billion-year-old secrets about the formation of the planets. Although it is one of the largest asteroids of all, Vesta is tiny compared to Earth, with a surface gravity that is only 2% what we experience on our world. Yet even such a tiny gravitational pull is enough to keep Dawn in orbit around Vesta. And soon after it arrived, in July of 2011, the spacecraft set about imaging the asteroid's entire surface end to end. Like other asteroids, Dawn has found that Vesta is riddled with craters. Each crater marks the spot where another smaller object has pounded Vesta's surface at high speed. Some craters are more recent than others, with clear, sharp edges. This group of 3 craters, imaged shortly after Dawn arrived at Vesta, is nicknamed the Snowman. Other features are more mysterious. As Dawn first approached Vesta, one of its first discoveries was a set of deep parallel troughs running roughly along the asteroid's equator. Although these troughs are not craters, Dawn scientists would eventually realize that they too are related to the large-scale collisions that have rocked Vesta in the distant past. The fate of an asteroid is determined by its encounters with others. In the early days of the solar system, asteroids such as Vesta were built up from smaller bodies that collided and stuck together. Many of these early clumps continue to grow and combine, forming full-sized planets like Earth. But in the location that is today known as the Asteroid Belt, it's thought that the strong gravitational influence of Jupiter, the solar system's largest planet, scattered the asteroids and kept them from forming something larger. Instead, many were broken apart by collisions, with fragments still occasionally raining down on Vesta right up to the present time. What makes Vesta an exception is that it has survived at its current size. Relative to most other asteroids, Vesta is a giant. And while it may look like an asteroid on the outside, there is evidence that Vesta could have a planet-sized heart. Most asteroids are thought to be the same inside and out. They have been built up bit by bit out of the dust and debris that swirled around the Sun when the solar system formed over 4.5 billion years ago. Dark and primitive, they are rich in carbon, oxygen, and other elements that are common throughout the Milky Way, the byproducts of the life cycles of the star. Vesta is known to be very different. By analyzing the sunlight that reflects off its ash-gray surface, scientists have found it is more like basaltic rocks found on Earth. Such rocks are created in the heat of volcanic activity, created when lava cools on or near Earth's surface. There are also meteorites with a similar composition, space rocks, thought to be pieces of Vesta, which were blasted off the asteroid and later tumbled to Earth. These precious fragments suggest that Vesta was a molten body in the distant past. But how could such a small, cold world have produced lava? The answer lies with the star. A supernova is the sudden death of a massive star and one of the most violent events in the universe. For a brief moment, a supernova can outshine all the billions of stars in a galaxy combined. As the explosion rips the star to shreds, matter that has been highly energized by the supernova flies off in all directions. Of the many kinds of atoms that are created in a supernova, one of the most important to astronomers is aluminum-26, a radioactive isotope that decays over hundreds of thousands of years. Because aluminum-26 is known to have been present as our solar system was forming, scientists now believe a high concentration of this material is what gave Vesta its original heat billions of years ago. But today, as dawn patrols Vesta's pockmarked surface, there seems to be no obvious traces of past volcanic activity. In a search for subtler clues, Dawn has paid close attention to the deepest part of Vesta's surface, near the asteroid's south pole. Even before Dawn arrived, scientists knew there was a dark feature here, which they quickly realized was the shadowed hollow of a giant impact crater. Scientists have named the crater Rhea Silvia. This computer-generated perspective, based on dawn imagery, shows what it would be like to swoop down on Rhea Silvia and fly around its outer perimeter. By adding false color, where red represents high elevation and blue the lowest areas, it's possible to see the structure of this enormous crater more clearly. Rhea Silvia is, without a doubt, the largest and most impressive feature on Vesta. Nearly 500 kilometers across, and 19 kilometers deep, it has a central mound that is more than double the height of Mount Everest. And as Dawn moved in for a closer look, it was soon clear that the giant crater was just as impressive in its details. Here, jagged cliffs protrude from the wall of Rhea Silvia, revealing the bedrock that lies beneath a thick blanket of impact debris. Further down, smaller impact craters with scattered boulders gouged out of Rhea Silvia's low-lying floor offer the most revealing glimpse at a part of Vesta that was once deep below the surface. Armed with these and other unprecedented views, scientists would soon discover that Rhea Silvia was the key that would help them unlock the 4.5 billion-year-old history of Vesta. But along the way, that key would also provide an unexpected turn. By April of 2012, NASA's Dawn spacecraft had brought itself to within 200 kilometers of the asteroid Vesta, much closer than the International Space Station orbits Earth. At such close quarters, Vesta's airless surface appears peppered with small craters, many of them produced when chunks of rock that were blasted off Vesta came crashing back into the asteroid. With Dawn's help, astronomers have now confirmed that the biggest blast of all came roughly 1 billion years ago, when a smaller asteroid collided with Vesta and formed its giant crater, Rhea Silvia. Now it appears that many of Vesta's unique features are tied to this ancient impact. But when Dawn began looking at Vesta's giant crater up close, it encountered another surprise. Rhea Silvia sits on top of another crater whose outline can still be seen. Nearly as large, but 1 billion years older, scientists have dubbed Vesta's second giant crater Venenia. So now it's clear that Vesta was twice hammered by a mighty blow. Each one raised its own set of ridges and troughs, and each one excavated tons of debris that were then scattered across much of Vesta's ancient surface. But while some of Vesta's past now lies buried by these giant impacts, there are pieces of it that can be examined up close. That's because the same two impacts that carved out Vesta's largest craters also shattered its crust and mantle, blasting enough rock into space to create an entire family of smaller asteroids. It is these pieces, known as Vestoids, which have occasionally found their way to Earth as meteorites, bringing us valuable clues about the nature and history of Vesta. Now those clues can be directly compared with the data that Dawn has gathered by orbiting Vesta up close. The results make clear that Vesta is a unique fossil from the solar system's deep past. At that time, its liquid interior divided into a metallic core and a rocky mantle, with minerals that become more iron-rich the deeper you go. In this way, scientists have found that Vesta is less of an asteroid and more of a miniature planet, an early result of the same process that would eventually lead to the formation of Earth in all its geologic diversity. Dawn's one-year encounter with Vesta has given us a close-up view and a new understanding of the solar system's ultimate survivor. But our explorations of the asteroids and the asteroid belt are just beginning. In the summer of 2012, Dawn's ion engine powered up and gently pushed the spacecraft out of its orbit around Vesta, putting it on course to rendezvous with the asteroid Ceres in 2015. And while Dawn moves on, Scientists are also imagining even more ambitious explorations of asteroids that are closer to home. They are eyeing the so-called near-Earth asteroids, which have drifted far from the main asteroid belt and over millions of years have wandered into our own part of the solar system. The nearest of these wandering neighbors is the asteroid Eros, an irregular chunk of flying rock nearly 35 kilometers long. This was the target of the NEAR Shoemaker mission, which orbited Eros in 2000 and even managed to touch down on the asteroid's boulder-strewn surface a year later. By 2019, NASA's OSIRIS-REx mission hopes to follow a similar strategy, closing in on near-Earth asteroids and capturing up to 2 ounces of material for return to Earth. Such missions hold great value for researchers trying to piece together the detailed composition and history of these nearest asteroids, and there are good reasons for doing so. Evidence suggests that in the past, asteroids colliding with Earth played a fateful role in shaping the history of life on our planet. In the future, near-Earth asteroids may become important in a different way, as a tantalizing opportunity for those seeking to harness these objects for their mineral wealth. Such a future will mean that the asteroids, which were long overlooked in the early years of space exploration, could one day become our main reason for venturing into space, and the next frontier in humanity's epic quest to reach for the stars.